Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 21 to 24 of the January 2017 Geometry Regents Common Core exam. All right, let's take a look at question number 21. It reads, in the diagram below of circle O, GO is equal to 8 and the measure of angle GOJ is 60 degrees. Question, what is the area in terms of pi of the shaded region? So what we're looking at here is the area of this shaded region, which is known as a sector, okay? A sector is a fraction of an entire circle. So let's go ahead and write down the formula for calculating the area of a sector. So let's write this down. The formula is as follows. Depending on the unit of the angular measure, that will determine what formula you're using, okay? So the area is theta, the angle, divided by 360 times pi r squared, okay? It's basically the fraction of the area. This is area right here. Theta over 360 is a fraction of the entire area. Multiplied by the whole area, that will give you the area of the sector. And this formula is applicable when theta is in degree form. And that is the case here. As you can see, we have a degree measure. If you're dealing with radians, the area is going to be 1/2 r squared theta. Okay, so this is when theta is in radians. All right, so to solve this problem, we just need two pieces of information. We need what theta is, the central angle, and the radius, okay? So let's go ahead and find theta first. So you need to be careful with this problem. We're looking for the area of the shaded region. So we're looking for this area right here. So we need this angular measure right here. That's what theta is, the angle that you add to 60 to get 360. Okay, so theta is going to be full circle, which is 360, minus the angle we have, 60. So theta is going to be 300 degrees. That's the central angle for the shaded region. Radius r is 8, as given here. So our area is 300. So let's rewrite the formula again so we don't get it confused. Theta over 360 times pi r squared. So we already calculated theta to be 300 over 360 times pi times the radius square. Okay? Now if you divide by 0, between 300 and 360, you have 30 over 36 times a squared is 64 pi. Now 30 and 36, what goes into both of them evenly? 6 goes, right? So 6 goes here, 6, and 6 goes into 35 times. And then 6, let's say 2 goes into 6 3 times, and then 2 goes into 32. 2 goes into 64 32 times. So we just have 5 times 32 times pi. That will give us the area of the sector. If you do with your calculator, you end up with 160 pi for the numerator over 3 for the denominator. All right? So that goes your final answer for question 21. All right, let's look at question 22. It reads, a circle whose center is the origin passes through the point -512. Question, which point also lies on this circle? So one fact you want to keep in mind is the connection between points on a circle and the center, okay? So you want to recall that all the points that define a circle are what? Are equidistant from the center, okay? If you think about the definition of a circle is a locus of points that are equidistant from a fixed point known as the center. All right, so this is the idea we're going to be using to solve this problem. So the distance from the center to the extremity, to the circumference of a circle is known as the radius, okay? So r, using the distance formula, has to satisfy the equation x minus 0 square plus y minus 0 square, okay? So basically the distance, let me show you a sketch here. The distance from the center of a circle to a point on the circumference, that's known as r, okay? So when you use the distance formula within the context of this problem, because we have the origin as 0, 0, and at any point you can call it xy, and then you apply the distance formula here, that's how you end up with this equation, because we know that the distance d is the square root of x2 minus x1 square plus y2 minus y1 square. Okay, so we apply the distance formula to a circle centered at the radius. This would be the formula for computing the radius. Okay, all right, so we have a point that's given on the circle, so negative 5, 12 is on the circle. So what does that mean? Negative 5, 12 is on the circle. So x is negative 5 and y is going to be 12. Alrighty. So now this will help us compute the radius. So the radius r is going to be the square root of x is negative 5 minus 0 square plus the y is 12 minus 0 square. Okay. All right, now let's go ahead and compute what the radius is. So 5, negative 5 minus 0 is just negative 5. When you square that, you get 25. Plus 12 minus 0 is 12 squared is 144. You add that together, you have the square root of 169, which is 3. We have a radius, actually 13. We have a radius of 13, okay? Now, what's the deal? How do we know which one is correct here? Now, any point, based on our definition, any point on the circle, this circle that satisfies this condition right here, must be what? It must be 13 units from the center, okay? Hence, it must be a pair, an ordered pair. It must be a pair, any pair xy that satisfies the equation root x minus 0 square plus y minus 0 square. This basically helps you compute the value of the radius of a circle centered at 0, 0. This has to be equal to 13 in order for xy to be on this circle under consideration. Okay, so what we're going to do is test the different options that we have here and see which one works. So let me test option 1. So you test, let's test 1. Option 1 is what? 10, 3. So in this case, x is 10 and y is 3. All right, so what we're going to ask ourselves is, does this ordered pair satisfy this equation right here? So we're just going to plug it in. Is the square root of 10 minus 0 square plus 3 minus 0 square, is it equal to 13? All right, let's work it out. 10 square is 100 plus 3 square is 9. Is the square root of 100 plus 9, is it, for the question mark there, is it equal to 13? Is the square root of 109 equal to 13? That's no. This is false. Hence, number 1 is not your answer. Now let's jump to the third one. Test 3. You can test the second one, but I'm just going to jump to the third one. Let's see what happens there. So for the third one, we have the ordered pair, 11 to root 12. Okay, so we have 11 to root 12, which follows that x is 11 and y is 2 root 12. So does it satisfy this equation right here? Let's see. So we have the square root of 11 minus 0 square plus 2 root 12 minus 0 square. Is it equal to 13? Let's simplify. 11 square is just 121 plus 2 root 11 square is 4 times 12. Is it equal to 13? Simplify this. We get root 121 plus 48. Is it equal to 13? If you add this together, you get 169. Is root 169 equal to 13? Absolutely. So our answer is option number 3.
Let's take a look at question 23. It reads, a plane intersects a hexagonal prism. The plane is perpendicular to the base of the prism. Question, which two-dimensional figure is a cross-section of the plane intersecting the prism? Okay, so what we're going to do is we're going to take a look at the diagram of a hexagonal prism, and then we're going to take a look at the cross-section that's created when you have a plane perpendicular to the base intersecting the prism. Okay, so here we go. This is a sketch of a hexagonal prism. So what we're going to do is use a plane to intersect this prism in such a way that the plane is perpendicular to the base. Okay, so this is what you get. Alright, so what outline is created here? You can clearly see that we have a rectangle. Okay, and it doesn't really matter how you cut or intersect the hexagonal prism with the plane in such a way that is perpendicular to the base, you will always end up with a rectangle. Okay, as you can see here, I'm just moving the point, and you still have a rectangle regardless of how the intersection is. Okay, so the answer is going to be a rectangle. Now let's take a look at another case. What if the plane was parallel to the base? Can you imagine what the cross section is going to be? If the plane were parallel to the base, you will have a hexagon. Okay, but that's not what the question is asking. The question is asking about a situation where the plane is perpendicular to the base. This is the base, the bottom right here, and the plane, as you can see, is 90 degrees to the base. So the answer to question number 23 is option 4, which is a rectangle. So this is like the 90-degree angle right here of the plane perpendicular to the hexagonal prism. Okay. So that's that. All right, let's take a look at 24. It reads, a water cup in the shape of a cone has a height of 4 inches and a maximum diameter of 3 inches. What is the volume of the water in the cup to the nearest tenth of a cubic inch when the cup is filled to half its height? So be careful here. In this situation, we have a cup filled to half the height of the entire cone. It doesn't fill it up all the way. Okay, so let's go ahead and write down the formulas that are going to be guiding our problem solving process. Alright, so the formulas that we're looking at are the formulas for the volume of a cone. Okay. Alright, so let's say the cone is filled completely with water. What would the volume be? Okay, the volume is going to be 1/3 pi r squared h. Okay. Remember, a cone has the same volume as a third of a cylinder with an identical base and height. Now, what if you have half full? If the not half full, sorry, half the height. Half full is something different. All right, so let's say it's half the height. What will the volume be in that case? The volume is going to be 1/3 pi. Now, when you're looking at half the height, not only does the height get halved, but the radius gets halved too. So you have the radius over 2 square times the height divided by 2. Okay, so let's go over why we have this formula looking like this. Okay, so this is the shape of the water cone that we're talking about. So what's happening here is that we have the base radius. This is r right here. And this entire length, this is h. Let me show you what the height looks like. So from the base to the tip of the cone, we have the height h. Okay, so the question is, what is the radius when we go halfway? Okay, so from here to here, that's the height h for the cone. But we're not looking for the volume of a cone that's completely full. It's halfway full, okay? So if it's halfway, this height is going to be half as big as the original height. Okay, let me just fix this real quick. So this one is going to be, this height right here will be h over 2. Okay, so that's the entire one is h, and this is h over 2. So if this is h over 2, now what is the base radius of the new cone, the cone that's half as tall as the original cone? What is that going to be? So since we don't know what it is, although I already told you it's r over 2, let's just call it x, okay? So the goal is to show you that this radius is going to be half of the radius of the base. To establish that, we're going to use the idea that we have two similar triangles. The big triangle and the small triangle are similar. You can use the asimilarity postulate to arrive at that goal. They both share this angle and they're both perpendicular to the base. So you have two angles that are corresponding and identical, so these two triangles are similar. Okay. So if the triangles are similar, that means that corresponding sides are in proportion. Okay, so the ratio of the height of the big triangle to the base radius is going to be equal to the height of the small triangle, which is h over 2, divided by the base radius of the small triangle, which we do not know. Let us call it x. Now let's go ahead and solve this for x, the radius of the cone that's half the height of the bigger one. To get x by itself, multiply both sides by x. Alright, so this cancels out. and then you have hx over r equals h over 2. Okay? Now, to get x by itself, we will multiply. We need to get rid of h over r. Alrighty, so we multiply both sides by the reciprocal, which is r over h. So times both sides by r over h. And then the r is divided out, the h is divided out. You have x equals, and then on the right side, the h is divided out, r over 2. So x is equal to r over 2. So you can clearly see that when you have a cone that's half the height of the original cone, the radius of the base will be half the radius of the base of the original cone. Alright, so that is why we have this r over 2 component here. So this is just a side point. Now let's go ahead and solve the problem. We already know what formula we're going to be using. We're using this formula right here for a cone that's half the height of the original. We need the radius, but we're given the diameter here. The radius is the diameter divided by 2, so we have 3 divided by 2, which is 1.5. The height of the cone is going to be half the height of the main cone, so it's going to be 4 over 2, which is going to be 2. Now let's go ahead and find the volume. Okay, volume of half height. That's going to be 1/3 pi times the radius over 2. So the radius is 1.5. So we have 1.5 over 2. That's the radius of the base over 2, and then we're going to square that. And then the height over 2, we already divided the height by 2, so we just put in a 2 here. All right, and then that will give us the volume. All right, so let's input it into our calculator. So we have 1 divided by 3, 1 over 3 times pi. So times pi, parentheses 1.5 divided by 2 square, okay, times 2. And our answer is 1.17. So we're rounding to the 10th place, or to 1 decimal place. So our volume of the cone that's half the original cone is going to be 1.2. Okay, so it's 1.2 cubic inches. Our answer for question 24 is option number 1. Alright, so just a quick point to note, I did h over 2, so let's just put a h over 2 here so that it matches perfectly with this formula. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very important to us. If you have any questions or comments, just place it in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on Mathgotserved.com. Thanks again for watching, and have a wonderful day. Goodbye.